In Chapter 11, we will learn the typical techniques used in speech synthesis. Firstly, let's have an overview of speech synthesis. Speech synthesis is a challenge task in the same way that mimicking any human function with a machine is difficult. Intelligible speech is relatively straightforward to generate. Natural-sounding speech synthesis is a task with limited achievements today. A text-to-speech TTS system converts normal language text into speech. Other systems render symbolic linguistic representations like phonetic transcriptions into speech. The quality of a speech synthesizer is judged by its similarity to the human voice and by its ability to be understood clearly. Long before the invention of electronic signal processing, some people tried to build machines to emulate human speech. In the year 1780, Val Campelen established an acoustic mechanical speech machine. This machine added models of the tongue and lips, enabling it to produce consonants as well as vowels. Small whistles controlled consonants. It had rubber mouth and nose. Nose had to be covered with 2 fingers for 9 nasals. If generating unvoiced songs, the mouth covered and auxiliary bellows driven by stream provides puff of air. A speaking clock service was first introduced in Britain in 1936, which is the first instance of practical text-to-speech synthesis. Mistaken voice was recorded optically onto the glass disc in a similar way to a film soundtrack. Photographic storage on a 4 glass disc, 2 discs for minutes, 1 for hour, 1 for seconds. Other words in sentence distributed across 4 discs, so all use 4 discs at once. The figure shows a technician adjusted the amplifiers of the first speaking clock. In the 1930s, Bell Labs developed the vocoder, which automatically analyzes speech into its fundamental tones and resonances. From his work on the vocoder, Homer Dudley developed a keyboard-operated voice synthesizer called Verder Voice Demonstrator, which he exhibited at the 1939 New York World's Fair. The Verder synthesized speech by electrical means and manually controlled through complex keyboard. The operator training was a problem. You can listen to the example of synthesized sound by Verder.
Will you please make the voter say for our Eastern listeners, good evening, radio audience?
Good evening, radio audience.
And now for our Western listeners, say, good afternoon, radio audience.
Good afternoon, radio audience.
Does it like a piano or an organ? Dr. Franklin Cooper and his colleagues at Huskin Laboratories built the pattern playback in the late 1940s and completed it in 1950. There are several different versions of this hardware device. Only one currently survives. The machine converts pictures of acoustic patterns of speech in the form of a spectrogram back into sound. Using this device, Alvin Lieberman and colleagues discovered acoustic cues for the perception of phonetic segments, consonants, and vowels. You can listen to the example of synthesized sound by pattern playback.
These days, a chicken leg is a rare dish. It's easy to tell, cook them so well. 4 hours of steady work faced us.
DEC Talk was a speech synthesizer and text-to-speech technology developed by Digital Equipment Corporation in 1984, based largely on the work of Dan Sklant at MIT, whose source filter algorithm was variously known as GLAD Talk or MIT Talk. DEC Talk TDS system has been developed for many years. It can be used as part of a speech-generating device for those unable to speak. A notable user is Stephen Hawking. This picture shows the early DEC Talk product with a cat for skill. Earlier, electronic speech synthesizer sounded robotic and were often barely intelligible. The PSOLA algorithm proposed in 1990 greatly improves the timbre and naturalness of synthesized speech based on the time domain waveform splicing method. From the year of 2005, speech synthesizers become cheaper and more accessible. More people benefit from the use of text-to-speech programs. The quality of synthesized speech has steadily improved, but as of 2016, output from contemporary speech synthesis systems remains clearly distinguishable from actual human speech. In the text-to-speech conversion system, the text must be analyzed in advance to determine how the tone of each word should be changed according to the context. And then, these tone-changing parameters are used to control the synthesis of speech. The 3 models of text analysis, pseudo, control, and speech synthesis are the 3 core parts of the text-to-speech system. The process of text analysis contains 3 steps. The first step is to normalize the input text, deal with users' possible spelling mistakes, and filter out irregular or unpronounceable characters. This process is often called text normalization. The second step is to analyze the boundaries of words or phrases in the text, determine the pronunciation of the text, and analyze the pronunciation of numbers, surnames, special characters, and various polyphonic characters in the text. Determine the change of tone and the way of different tone in pronunciation. The process of assigning phonetic transcriptions to words is called text-to-phoneme. Finally, the input text is converted into internal parameters, phonetic transcriptions, and prosody information that can be processed by the computer, so that subsequent models can further process and generate corresponding information. Anyone speaks with prosodic features including different tones, pauses, and different pronunciation length. The prosody parameters include acoustic parameters that can affect these characteristics, such as pitch, duration, and amplitude. In the end, the specific prosodic parameters that the system can use for speech synthesis rely on the prosodic control model. The speech synthesis model of TTS system generally uses waveform splicing to synthesize the speech, the most representative of which is the pitch synchronous overlap add method, PSOLAR. In summary, the synthesis system firstly converts raw text containing symbols like numbers and abbreviations into the equivalent of written out words, which corresponds to the stage of non-words to words. Then, it assigns phonetic transcriptions to each word and divides and marks the text into prosodic units like phrases, clauses, and sentences, which corresponds to the stage of words to phonemes. Each phoneme has a standard duration and is then modified by inserting pauses at punctuation, such as pause after long phrase, pause before the connection word joining two sentences. The prosodic information contains suprasegmental characters of speech, like intonation, rhyme, and stress. Phonetic transcriptions and prosodic information together make up the symbolic linguistic representations, which is then converted to the sound by synthesis model. That's all for this session. See you next session.